Greetings. Welcome to the AWS Summit. My name is Evgeny Vaganov. I'm a specialist solution architect based out of Sydney, Australia. My specialty in AWS is networking and network security services. And today I'm presenting on AWS Network Firewall and network security in Amazon Virtual Private Cloud, or simply Amazon VPC. Let's see what is the agenda for the session. First, I'm going to give you a very brief history of network security in Amazon VPC. Next, I'll focus on new services and features built in 2020. I will very importantly cover why did we build these new services and features. We will also together take a more detailed look at the functionality and how to deploy these new services. We'll also see a demo of AWS Network Firewall. And we will finish with a recap of main points covered in this session, and the next step you could take in your own AWS environment. As a reminder, this is a 300-level session. Fair understanding of Amazon VPC, routing, and network security is expected. Okay, let's move on. Amazon VPC was released in 2009. Over the years, we have built many preventative controls, which allow you to prevent, or in other words, stop networking traffic. We have also built many detective controls, which allow you to examine logs, metrics, and also take reactive actions based on findings. In 2020, we have added two new DNS-related features. The first one is the ability to log Amazon VPC resolver originated DNS queries. And the second is to enable DNSSEC validation in your Amazon-provided DNS resolver. Today, however, I'd like to focus on the two other significant services, AWS Gateway Load Balancer and the AWS Network Firewall. Okay, let's not spend any more time on history and move to the more important topics with a focus on these two new services. So what did we build? And most importantly, why did we build? In 2020, we released AWS Network Firewall, a new network and application layer traffic filtering service. It addresses some frequently requested use cases, such as filtering of domain names for protocols like HTTP and HTTPS based on host header for HTTP and server name identifier or SNI in TLS protocol. It also supports thousands of rules, much higher than the number of rules if compared to security groups or network ACLs. Typically deployed at the perimeter of your VPC for internet-bound traffic or along with AWS Transit Gateway for any desired traffic flows. It also has a rich partner integration story with managed rule sets, monitoring, and deployment integrations. Let's now take a more detailed look. Here, you can see at the top customer's responsibility and at the bottom AWS responsibilities when it comes to AWS Network Firewall. Let's start with the bottom. AWS is responsible for managing the firewall, the scaling. We provide you with an SLA and take care of all underlying management and maintenance aspects, just as you would expect from a managed AWS service. As a customer, it's easy to get started with AWS Network Firewall by visiting the Amazon VPC console to create or import your firewall rules, group them into policies, and apply them to the VPCs you want to protect by deploying firewall endpoint and configuring VPC routing to use the endpoints. You can also use Firewall Manager to govern multiple AWS Network Firewalls across your AWS environment. Now, I'd like to focus a bit more specifically on the firewall endpoint. The firewall endpoint under the hood is powered by the AWS Gateway Load Balancer. What is AWS Gateway Load Balancer, you may ask? It is a building block which allows for a single entry and exit point, and it load balances any network traffic to the backend network appliances. As example, a compatible virtual firewall from one of AWS partners. It allows you to elastically scale the appliance fleet and performs appliance health checks, and so it can detect appliance failures and automatically recover from it. There are many AWS ecosystem partners which integrate with AWS Gateway Load Balancer, and some of this may be already used in your existing AWS environment. AWS Gateway Load Balancer can make these appliances look, feel, and behave more cloud native. Let's take a quick look at how AWS Gateway Load Balancer works under the hood. AWS Gateway Load Balancer, or GWLB, has two key components: the endpoint, or GWLBE, which sits in the path of networking traffic, and the load balancer itself, which is a place in front of your appliance fleet. The appliance fleet is typically an autoscaling group. Both load balancer components are powered by AWS Hyperplane, which is a highly available network function service which powers AWS services like NAT Gateway and Network Load Balancer. The benefits of this architecture is that you can horizontally scale your appliance. Traffic remains sticky, allowing for stateful inspection. If appliance failure is detected, new flows will be sent to healthy appliances. You can build a separate network security function and deploy it into desired VPC. Deployment is simple. Build a security VPC with the load balancer and the firewalls, and present the endpoint into one or more VPCs, just like you do with AWS Private Link. Now, I'd like to emphasize one point. Gateway Load Balancer is already inbuilt into AWS Network Firewall. If you deploy AWS Network Firewall, you don't need to deploy Gateway Load Balancer separately. You only deploy AWS Gateway Load Balancer if you need to bring your own appliance. Now, you probably have some questions by now on how these two new services compare against existing network security controls you are already using. Here, we'll take a look side by side and compare with security groups, network ACLs, and AWS Web Application Firewall, or simply AWS WAF. If we look at key use cases, Network Firewall is concerned with traffic filtering and intrusion prevention, whereas Gateway Load Balancer plus appliance are appliance functionality dependent. It's going to be a similar story for other categories, with Gateway Load Balancer plus appliance. Security groups and network ACLs, in contrast, just allow or deny traffic. WAF is looking specifically at HTTP application layer items like protection for bots or performing input validation. Both AWS Network Firewall and Gateway Load Balancer are inserted exactly the same way into the traffic path. Security groups wrap around your ENIs and network ACLs around subnets. WAF integrates with web-based resources only and doesn't impact any other traffic. Network Firewall combines stateful and stateless traffic inspection engines. Traffic has to go through stateless first, and depending on the rule settings, may be passed on to stateful for additional inspection. Stateless allows for very low latency processing. The others you can see for yourself. They're either just stateful or just stateless. In terms of OSI layers, Network Firewall operates across layer 3 through to layer 7 and has support for common application protocols. Other categories are simply layer 3 or layer 4, or layer 7 specifically. Network Firewall can take different actions on your traffic. The default is a pass, or allow in other words. As I have mentioned before, AWS Network Firewall integrates with Firewall Manager for simplified governance in multi-account and multi-VPC environments. And finally, except for inbuilt Amazon VPC security controls, all others come at additional cost. Now, I'd like to briefly discuss how to deploy the services. Before, you had typically a single primary virtual firewall instance, and it will fail over traffic to a standby by updating VPC route tables or shifting an ENI. Now, with new services, you simply insert them into a traffic path, and they take care of HA under the hood. With Gateway Load Balancer, you obviously have to take care of management and maintenance of your appliance fleet. If you think about deploying at scale, where you have multiple Amazon VPCs, you can deploy AWS Network Firewall individually into each of your VPCs, and you can also make use of Firewall Manager if required. Some organizations may have VPCs talking to each other and also to Internet. A very common here is to centralize Internet access point. As example, with Transit Gateway, you can deploy Inspection VPC and selectively send east-west or VPC to VPC traffic, and also north-south traffic, such as internet-bound traffic. This approach allows organizations to avoid resource duplication and is more economical. Now, I'd like to briefly mention one very important feature of AWS Transit Gateway. This is something you must enable to ensure traffic symmetry in your AWS network. Essentially, you can enable something called AWS Transit Gateway Appliance Mode in your inspection VPC attachment. And it will keep traffic symmetric when it comes to the firewall endpoint, irrespective of the AZ which originated traffic. This is a must for stateful traffic inspection. I'm not going to spend much more time here, but if you have Transit Gateway, you just must memorize that this capability is required for stateful network appliances. Okay, so at this point, I want to show you how to combine multiple AWS services together and protect your VPC. We start with the workload, which can make use of private subnets, security groups, and network ACLs. We can have reverse proxy for traffic such as ALB and NAT gateway to forward traffic in public subnets. All of the internet traffic will go via firewall endpoint where traffic can be filtered. Before traffic even gets into your Amazon VPC, we can have CDN integrated with WAF and AWS Shield to mitigate web application and DDoS attacks. And finally, we have many detective controls provided by other AWS services. Use them together to protect your Amazon VPC. Now, I'd like to show you what AWS Firewall looks like in action. This is a diagram of my demo environment. At the bottom, I have two Spoke VPCs with an EC2 instance in each. I can access both of them using Systems Manager. They're connected using Transit Gateway, and I have deployed a centralized internet egress point with a firewall and also a separate firewall for east-west inspection. Okay, now let's take a look at the demo. So here you see my demo environment. I already have a couple of EC2 instances provisioned, Spoke A and Spoke B, and they are placed into different VPCs. So that's all ready to go. If I have a look here, this is my Systems Manager screen, and I can access and ping one instance to another. This is my second instance that's ready to go. And if I have a look at my Amazon VPC console, under my VPCs, you can see the 4 VPCs provisioned as per my demo architecture. There's a couple of VPCs there for workloads and a couple of VPCs for my firewalls. Now, if I take a look at subnets and just show you a little bit of routing and how that's configured. So this is my typical workload subnet. You can see my default route points to my Transit Gateway attachment. If I look at one of the inspection VPCs, you can see the inbound traffic goes to my firewall endpoint. If I take a look at the firewall subnet, you can see the return traffic goes to my Transit Gateway attachment, and the default points to NAT gateway. Now, let's take a quick look at the Transit Gateway itself. So this is the Transit Gateway, which has been provisioned. The 4 different attachments are in place, and I do have a couple of route tables. The first route table is for my Spoke VPCs. And you can see here, I've got a couple of static routes, one for my default egress VPC, and another one for my east-west VPC. So that has the local private route. Now, this is important because this allows me to send traffic through my inspection VPCs. Now, let's take a look at my firewalls. The first one is the inspection firewall. This is my east-west firewall. Now, I don't have any stateless policies in place at the moment. I'm passing all the traffic to my stateful inspection engine, and I only have one rule configured. I'm allowing ICMP traffic. So now, what I'm going to do, I'm going to start denying the traffic. I already pre-created my ICMP deny rule in my stateless engine, and we remember that the stateless engine is the fast processing engine. So this is good if I want to immediately drop traffic, for example. And I'm going to be dropping my ICMP traffic. So if I go back to my sessions manager and try to ping again, you can see I'm still successful, right? That's because the rules get applied asynchronously. And now you can see the rule has applied, and I'm actually dropping packets. So that's expected. When you're doing it in your own environment, you should expect the rules taking a little bit of time to apply to the firewall. Now let's do another test. I'm going to run SSH from one instance to another. I'm using a custom port, 8022. And you can see here, the traffic works. I'm not passing any username and password or private key, but SSH session works. You can see the permission denied message. Now, if I go back to my firewall and show you the rules again, you can see I have simply a single rule that allows to pass traffic. Why is my SSH working? Well, that's because the default is the pass, and all the traffic is allowed. Okay, now I want to modify my default behavior and actually change to default deny for the traffic. So what I'm going to do, I'm going to change my stateful rules and attach a new rule group. And this rule group will deny traffic. So let's take a look at the rule itself. In here, I'm dropping any TCP traffic. And also, I'm only dropping it for the traffic that has been established. In other words, the TCP handshake has been completed. So I'll go ahead and run this test a few times more. As you remember, we have changed default behavior, so now we should be dropping this traffic. And it's taking a little bit of time to asynchronously apply it to the firewall. So I'm going to run this test a few times more. And now finally you can see I'm not getting permission denied message anymore. I'm going to go verbose and just show you that while the connection is being established, right, the TCP handshake actually happens, I'm dropping the flow once it has been completely established. That's exactly what my rule said. Yeah, and the session does not continue any further. So now let's go back into the firewall console. So this is my rule, and this is the established traffic being dropped, right? So the firewall does exactly what I've asked it to do. Okay, so now that we've seen this rule, let's do a little bit more with this firewall. So now we're going to allow SSH traffic to come through, but we're not going to specify any layer 4 rules, right? So we're not going to actually specify any IP addresses, source destination, source ports, or anything like that. We're just going to detect our SSH protocol and allow it, irrespective of what port we use. And that's where our custom port is going to be handy. Yep. So as you can see here, SSH is allowed. This is the new rule, right? And it's in place. So now let's go back into our screen and give it a quick test. So before, you remember, it wasn't working because we were dropping traffic, and now we're allowing it. Yep, and it works again. So the change already has taken place to the firewall. Excellent. So you can see it here, both layer 4 and application layer 7 rules are working together. Now, let's go back and have a look at our egress firewall. This is the firewall we use for internet access. So in here, I have one rule, and this rule is denying ICMP traffic. So my ping to the outside world will not work. So let's go ahead and ping something like aws.amazon.com. And as you can see here, it doesn't work. So that works as intended. Excellent. Now, what about if we send a web request using curl utility to the same website? We remember that default is allow. And then you can see the traffic passes through. So now, what we'll do, we'll actually use the domain name filtering capability of the AWS Network Firewall. So let's go back and attach a rule group that I pre-created earlier. So we're attaching this rule group now. As you can see, it has been attached. If we go inside and take a look at what we're actually allowing, in here we're allowing anything under Amazon.com domain for HTTP, HTTPS traffic, and the action is allow. So this will continue to allow our traffic. Okay, so let's test it again. We expect it to continue to allow because that's the subdomain of Amazon.com. But what about if we go to some other domain name? For example, example.com. You can see here the traffic is being denied now, and we're not getting any response back. So let's go verbose. As you can see here, we are actually establishing connection. So we are doing TCP handshake. But as soon as we send HTTP head, in this case, with our host header that doesn't match our allowed list on the firewall, we're not allowing the traffic. And now I will go ahead and add example.com to the allowed list of domain names. Let's save it. So now, once the change is applied, we'll be actually able to connect again and get a response back. As you can see here, we rerun the same command, and now we're getting response back because we just allowed this domain name for HTTP protocol. Excellent. And finally, we'll take a look at the CloudWatch logs. Here you can see that I'm logging both flow and alert logs for the firewalls, both of them. And the entry that I'm going to show you is the entry for the application traffic. We are denying SSH traffic. And as you can see here, we're detecting the type of traffic as well as all the layer 4 information as well. So now that you have seen AWS Network Firewall in action, what should you do next? First, figure out if there are use cases where AWS Network Firewall or Gateway Load Balancer could help. If you have preference to use your existing appliances, where you have made years of investment, Gateway Load Balancer would be a good choice. If you want to start fresh, Network Firewall is easy to deploy and maintain. Pick the best option and deploy to non-production to gain experience and create your rule sets. Make sure to apply well-architected principles, look for cost optimization opportunities, and create your operational runbooks. And finally, you will be ready to deploy to production. A good place to start with AWS Network Firewall is the Firewall solution published online. It integrates with your existing transit gateway, and it creates a full infrastructure as code pipeline for ongoing rule maintenance and updates. It also deploys in a multi-AZ environment. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for networking. For more information, visit aws.training/networking. Similarly, there are other security services you should learn about. You can find more at aws.training/security. And don't forget to get certified. This can be a good enforcement mechanism to achieve the breadth across different services and tools. Okay, let's recap on what did we learn today. First, AWS Network Firewall is an easy-to-use and deploy for both network and application layer traffic. We also learned that Gateway Load Balancer allows you to bring your own network security appliances. We make them look and feel cloud native. We also briefly mentioned about AWS Transit Gateway Appliance Mode, which is required for traffic symmetry and for stateful firewalls. And finally, how can we use all these different services together to achieve defense in depth for your Amazon VPC? With that, I'd like to thank you for attending this session. Thank you very much. And please, don't forget to leave us feedback. We use the feedback to make these events better. Once again, thank you and enjoy the rest of your AWS Summit.